Thus, the Powerpuff Girls were born!
Girls, help me! Mr. Mayor asked me to get the statistical data of foot sizes and height of each mother here in Townsville, but I can't do it myself.
Each mothers in Townsville? That's a lot!
Well, duh, we don't have a choice. So how do we start this one?
Okay, I've heard about this thing, old measures of variation. Miss Ken told me that it is the most convenient way to get this task done, but I don't have any idea about it.
Don't worry, Miss Bellum. We just search it in Google.
Right! Okay, let's see. So, measures of variation describe the width of a distribution. They define how spread out the values are in a data set. They are also referred to as measures of dispersion or spread. Measures of variation are used to summarize data and draw many conclusions, such as high and low variability. They are also used to measure, analyze, or describe the trends in the dataset. Because variability can provide a lot of information about data. It is important to know the different measures of variation. The range is one of the most basic measures of variation. It is the difference between the highest and lowest values or between the smallest and the largest data item in the set. While a large range means high variability. A small range means low variability in a distribution. To find the range, first put all numbers in order. The range is calculated by subtracting the lowest value from the highest value. The range generally gives you a good indicator of variability when you have a distribution without extreme values. When paired with measures of central tendency, the range can tell an individual about the span of the distribution.
The mean deviation is defined as a statistical measure that is used to calculate the average deviation from the mean value of the given data set. Mean deviation can be calculated about the mean, median, and mode. The general formula to calculate the mean deviation for ungrouped data is the mean deviation is equal to summation of an absolute value of x minus x bar over n and group data delta. X bar is the mean deviation. True mean is equals to summation of f mode of x minus x bar over summation of f. So, to solve mean deviation, first, you must find the mean of all values, then find the distance of each value from that mean, or subtract the mean from each value or ignore minus signs. And lastly, find the mean of those distances.
For any distribution is sorted in the ascending or descending order, half of the values are in the interquartile range. The second and the third quartiles, or the center half of the data set, make up the interquartile range, or IQR. We'll use the formula to calculate the interquartile range volume. IQR is equals to Q3 minus Q1, with IQR denoting the interquartile range. Q1 stands for quartile 1, or the lowest quartile, and Q3 stands for quartile 3, or the top quartile. So, we'll just subtract the value of quartile 3 from the value of quartile y. There are 4 steps to determine interquartile range. First, sort the data from smallest to largest. Second, find the median, which is the data center. Third, calculate the median of both the lower and upper half of the data. Fourth, calculate the difference, subtract the lower median from the upper median to find the difference between the upper and lower medians. The quartile deviation is calculated as half of the difference between the upper and lower quartiles. QD denotes quartile deviation, with Q3 denoting the upper quartile and Q1 denoting the lower quartile. QD is equal to quantity of Q3 minus Q1 divided by 2 is the formula for point elevation of data. So, to calculate quartile elevation, first, determine the Q1, then determine the Q3, then subtract the 2, and last divided by 2 for open-ended data. This is the one of the best dispersion strategies.
Alright, I'm getting the idea of it.
The variance is a measure of variability. It is calculated by taking the average of square variation from the mean, where areas it tells you the degree of the spread in your dataset. The more spread of data, the larger the variance is. In relation to the mean, the standard deviation is derived from the variance and tells you on average how far its value lies from the mean. Its square root of variance both measure your log variability and its distribution, but their units differ. Standard deviation is expressed in the same units as the original values. Example, meters variance is expressed in much larger units. Example, meter squared. Since the unit of variance are much larger than those of a typical value of dataset, it's harder to interpret the variance of numbers intuitively. That's why standard deviation is often preferred as a main measure of variability. However, the variance is more informative about variability than the standard deviation, and they use in making statistical parentheses. The easiest way instead to get the standard deviation: Step 1. Find the mean. Step 2. For each data point, find the square of its distance to the mean. Step 3. Sum the values from step 2. Step 4. Divide by the number of the data points. Step 5. Take the square. How about this thing called Z-courses and box and whisper? Tots Miskin said that it will be real convenient for Mr. President if I'll be able to have those of 2.
Ha 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 ha. Oh dear, look at you fretting over something as simple as that score.
Really? Then, why don't you just tell us about that instead of plainly bragging, Mojo?
Well, then I'll explain it. In the simplest form that your brain can grasp, that Z-score is a numerical measurement that describes a value's relationship to the mean of a group of values, as that score is measured in terms of standard deviations from the mean. If the Z-score is 0, it indicates that the data point score is identical to the mean score. Z-score tells us how many standard deviation in an observation is from the mean. For example, a Z-score of -2 tells us that we are 2 standard deviations to the left of the mean, and a Z-score of 1.5 tells us that we are 1.5 standard deviation to the right of the mean. Most importantly, as that scores allows us to calculate how much area that's specific. This score is associated with, and we can find that exact area using something called a Z-score table or standard normal table. Z-score are often used in academic settings to analyze how well a student's score compares to the mean score on a given exam. For example, suppose that the scores on a certain college entrance exams are roughly normally distributed with a mean of 82 and a standard deviation of 5. We calculate a Z-score by using the formula Z is equal to x minus mu divided by sigma, so we simply subtract the raw score to the population mean and then divide it with the population standard deviation. Now, to answer our situation earlier, let's say a student receives a 90 on the exam. Then, by using our formula, we will get the final answer, which is a Z-score of 1.6 which means that these students receive a score that is 1.6 standard deviation above the mean.
I'm sorry, I overheard your conversation. It seems like none of you knows the box and whisper plot. Well, a box and whisper plot is defined as a graphical method of displaying variation in a set of data. We use box and whisper plots when we have multiple data sets from independent sources that are related to each other in the same way. For example, test scores between schools or classroom. Now, how do we make one? Minimum value, the smallest value in the set of data. Second quartile, the value below which the lower 25% of data are contained. Median value, the middle number of range of numbers. Third quartile, the value above which the upper 25% of data are contained. Maximum volume, the largest value in the data set.
Wow, now I know how it works. Thank you so much, everyone. I owe this to all of you, and I will surely apply everything. I will truly apply everything that I've learned. Thank you.